The friction force exists whenever we have two surfaces in contact. It opposes the motion of the objects relative to each other. It is not always present for objects at rest. It is present or manifested only when it is needed to oppose motion. For example, a block on a ramp is subject to friction force if it is at rest. That friction force prevents it from sliding down the ramp. But a block on a flat surface is not going to experience friction unless it is being pushed and it's still not moving. Friction is due to a combination of atomic scale interactions between the atoms of the two objects and visible effects, visible features of both surfaces, like how rough the surfaces are, how smooth they are, etc. In magnitude, the friction force is related to the perpendicular or normal force through this simple expression. Friction force is equal to a coefficient of friction, mu, times the perpendicular force, the magnitude of the perpendicular force. Mu is going to depend on both surfaces involved. Things to remember about friction: it is always parallel to the surface, always points in the direction opposite to the net effect of all other forces. Now here we have the friction force acting on the top block, and here is the friction force acting on the table here. Notice how they are in opposite direction. So we need two contact surfaces, and this is the relationship between them. We talk of two types of friction: static friction and kinetic friction. Static friction is when the surfaces do not rub or slide against each other. Static means no motion. So when they don't rub or slide against each other, we have static friction. So for example, if I have a block here and I start pushing on it, and probably you have seen this already in lab, as I start pushing on it, it does not move, it does not move, it does not move, and eventually there is a break point where it starts sliding. So we have static friction all this time here when it's not moving. And that static friction value gradually increases up to a maximum value while the object is at rest. So the static friction force is always smaller or equal to that maximum value. And what we call the coefficient of static friction is the one that corresponds to that maximum static friction force. So again, if we are pushing on an object and it's not moving, the static friction keeps on increasing as we keep on pushing, till we reach a maximum value that the static friction force can have. That's when it starts sliding and we don't have static friction anymore. And the coefficient of static friction, which depends on both surfaces, is obtained when we write the maximum static friction force equal to μs times the perpendicular force between both surfaces. Now, kinetic friction is when the surfaces slide against each other. When there is motion, they are sliding. They have to be sliding against each other after they break free. Now, normally, in most cases, kinetic friction is smaller than the maximum static friction. What kinetic friction tries to do is tries to stop the object from moving. So it is opposite to the direction of motion of the object. The value for the kinetic friction, it's not like static friction that changes from 0 to a maximum value. It's going to be essentially constant. And that in magnitude, that kinetic friction force is given by the coefficient of kinetic friction times the normal force. And again, that coefficient of kinetic friction is smaller than the coefficient of static friction. A couple of important points. The coefficient of friction, this is counterintuitive, but the coefficient of friction does not depend on the contact area, the size of the contact area between both surfaces. It's counterintuitive, but it's important to remember that. It does not depend on that. And it also does not depend on the speed of the objects relative to each other. Both of these are counterintuitive, but they are important.